Alright, we're back, and I've turned the mic volume down a little bit. I was kind of watching the last video. It seemed like seemed a little loud. I don't know. Depends, on your volume, things like that. Anyway, let's go here. Let's go back. Let's mute this real quick. Go to the last video. It's been about, I don't know, it's been a couple hours, so I want to see exactly where we're at, what we're doing. Alright, we're going to crash Shadowrun. See, we have this open. We're going to crash Shadowrun. Going to BS about that. Then we're going to do some Python goofiness. And I've also added the Steam Plus cheat engine thing. We'll talk a little bit about that. Something I probably should have covered in the first video, but as in the very first video of the series, because if you well, whatever. We'll get into that. Sunday Fun Day. That looks funny. So we want to crash the game. How are we going to do that? Well, first we have to start the game. Alright. Are we going to go into load game or anything like that? No, we're not going to bother with that. We just launched the game. It's right here. We're going to attach, we haven't actually done anything in it. Attach cheat engine here. So what we're starting to do is go down to Pointer and do a whole lot of this fun stuff. And, is that right? Why is it not, let's try it again. There we go. Maybe I hit space or something. Nope, I don't know. Maybe it was a typo. So we were going to start, adding offsets, messing around, and pointing to different locations in memory. We're not going to do that. We're still going to crash the game, but instead of doing the pointer, we're just going to use the address box up here. So what are we going to do? Just going to do that. So it means the same thing as it did down here. If we typed it in here, we'd essentially substitute the same thing, but instead we're just going to use the apps or just use this as this location in the computer's memory. Hit OK. Some representation of the address down here, and we have a value. What are we going to do? We can change this to really anything. It's just like we were talking about. It's just bits. So we're just going to make it 0. Now, how are we going to make this game crash? I don't know. Let's make sure it's still 0. Click on a couple menus. Force it to calculate some internal state. See what we get. Let's click on content. I don't know. It doesn't seem to be working. Try continue. There you go. It has stopped working. It is checking for a solution to the problem. I highly doubt it will find a solution to the problem because we're the ones that cause that problem. We're going to close the program. So what did we just do? Let's do that again. So before we jump into exactly what we're not going to talk exactly about what we just did, but we just crashed the program. Can we was that a complete fluke, or can we do it again? We could do it again. Let's do it again. Type in the same thing, change this value. We'll try something else. We'll make that value 5. Click continue. And it crashed again. So fortunately for us, or unfortunately for the application, you can see that by fiddling around with values in memory, you can absolutely crash applications. So maybe let's jump into this a little bit more. We're not going to get super involved in this topic because we're just sort of screwing around, having fun. Or at least I'm having fun. So open this back up. Grab the process. Nope, we don't want to keep it. I suppose we could have, because it's really just we could have said yes probably, but all right. Doesn't matter if we change this value. Is there a certain range that of values or whatnot that we can put in this memory locations, 4 bytes, whatever, that will crash this game? I don't know. Let's change it by 1. See what happens. Go to continue. Yep. So can we illustrate this? Not really, because in order to figure out exactly why we'd have to could we figure it out? Honestly, off the top of my head, I don't know. But I imagine if we were gonna do a video or whatnot about trying to figure out what's going on and why this is crashing, we'd probably wind up opening the memory viewer here. You're not gonna see anything, and that works to our advantage for this time. There'd be some assembly code. There'd be some opcodes. There'd be a whole lot of stuff floating around. That's it's just I don't know. Yeah, we'll go back here. We'll reattach it. What do we mean by assembly language and opcodes and stuff like that? Well, that's exactly what we mean right there. Here's the Shadowrun process. Here's some offset, some bytes, things like that. You know, some opcodes. Here's some assembly code over here. And if we really wanted to, we could probably go to an address, figure out, you know, what's the we could probably figure it out. It's not important how or what, but it's there if you want to. And you know, maybe we'll jump into that way in the future, but we're not going to do that. So basically, we're going to crash this one more time, but we're going to try and be a little more illustrative about what we're doing. Add address manually, leaving the process name there. It's represents some address or some memory location, as the case may be. It has some bit pattern, and that bit pattern in the context of 4 bytes is that. Let's make this 8 bytes. See what we get there. You can actually, if you look up here and then you drag your mouse around in the list here, you can actually see that Cheat Engine will dynamically say or dynamically change the value or interpret it's not actually changing the value as we talked about. What it's doing is it's reinterpreting a bit pattern in whatever location is specified by Shadowrun.exe as a different type. So you see a float is approximately is about 6.3 with the bit pattern. Bit pattern is the same. We're just interpreting that pattern as a float. It's 1.3 as an 8-byte integer. That bit pattern is some huge number. It's 4 bytes. Still a large number, but somewhat smaller. 2 bytes, 23,117, 77 as a byte, and it has no idea what it is in binary. What is it going to say for text? MZ. Okay. It's an array of bytes. It's just an array of bytes. Let's make it 8. Hit OK. Change this value to 0. What is this memory location that we're changing? We have no idea. Typically, when an application starts up, the first block of locations, you know, what do we mean? How big is a block? Totally arbitrary. Completely application independent. But suffice to say, there's a chunk of memory that starts right at the beginning of the memory associated with the process. Typically has a whole lot of very critical operating system dependent state information. You know, and what do we mean by state information? Well, I don't know. What's sort of a high level generic concept that we could use to say? Doesn't matter. There's a whole lot of critical information. Or generally, we're going to say that there's a whole lot of critical information at the start of memory blocks that are associated with the process. So how are we crashing this game? Well, what we're essentially doing is we're putting 0 here, and when we click OK, Cheat Engine is going to take 0. It's going to say what is 0 as an 8-byte integer. What is the bit pattern that represents 0 for 8 bytes? Well, a byte is 8 bits, as we talked. Then you have 8 bytes, so now you got 64 bits. You got 64 zeros, or 64 binary digits that all have a value of 0. So essentially what we're doing is we're blanking out, or zeroing out, the first 64 bits of this process. And we're going to click OK, and we do that. Now, is it immediately rechecking that state information? No. Can we force it to do it without clicking one of these buttons? Maybe. Let's try minimizing it. You know, I don't know. We'll go through a few events here, see if we can maximize it. We can't really do that. Go to options, not crashing, content, whatever. Let's go to continue again. That whatever information was in the first 64 bits of this process is gone. The process is unable to continue functioning without those bits because it holds some internal state, and Windows is basically telling us that that application is toast. It's out to lunch. So is this specific to Shadowrun? It is not. We're going to cut this information out of Notepad, and we will put Cheat Engine against Notepad, or attach it to it. Do we want to keep it? No. What are we going to do? We're going to add an address. Instead of Shadowrun, we're going to call it notepad.exe. I don't know why it's not. Oh, because we didn't actually attach to the process. We did something wrong. Nope. But in fact, it is attached to Notepad right here. So now we'll type Notepad. We'll retype notepad.exe. It will give us some arbitrary location, some address. We'll change this. It doesn't matter if it's 4 bytes or 8 bytes, but we'll make it 8 bytes. Just to be in line with the previous example. We will change this to 0. We will go to Notepad. We will type some things. We will hit enter. We will type some more things. We'll run through a couple menus, see what's happening. Click and view help. Nothing's happening. That's interesting. I would call that spurious behavior. There's something going on with this program. It will bring up the about. See if it'll bring up the font. It will. I don't know. Edit. So click that one more time. Are we just missing what it's coming up with? There's some status bar. There is not. Edit. Time and date. Oh, we got a little bit there. That's working. Select all. All right. Let's go to print. Oh, there you go. We just forced it to recheck some part of that memory that we zeroed out, and that program is toast. Let's open it back up, and let's check the time. All right, we can crash this a couple more times. We go to File, we go to Print. Obviously, it's working fine. It's very happy with itself. It can do whatever we want. Let's go over here, see if we can get some view help. We can, in fact, get some view help. So there is something in the first 64 bits of this program that is related to view help. It's related to printing. See if we can find anything else. In the first, just, we're not finding anything really. We're just, we know that the first 64 bits contain some state information for this application that is relative to what it tries to do when we go to view help and when we go to print. So, did we do that? 344. 344, we did do that. All right. So add the address, Notepad. Let's paste this back in. There's no reason we just pasted it back in just because I have that address. We'll leave it at 4 bytes, so we're only going to obliterate the first 32 bits of memory. Does view help still function when we use 4 bytes? It does. So if we wanted to be really crazy about it, we could say, oh, well, somewhere in the between bits 33 and 64 is some bit information that it uses when we calculate help. We got to sort of speed up here. Got about a minute. Go. What else? What broke last time? We go to print. That's going to crash. So first 32 bits cannot print. Do this one more time, real fast. Paste this back in. Attach cheat engine to Notepad. Nope. Just so we can do that. Illustrate that one more time. We will leave it at 4 bytes. We'll change it to 0. And then we'll do something else. Let's go to File, Open. Does it crash? It does. So once again, you can see we are not making stuff up. If you start pushing random values or incorrect values in the context of an application into random memory locations, you will not just, maybe you won't crash the program, but you will start confusing the program as to its own internal state, which may cause it to crash. It may not. So again, we've clearly demonstrated that we can pretty much crash programs on demand by blanking out bits in the first small section of memory.